Alright, so the first thing that we're going to do with all of our equations is try to get them into row echelon form. And that's an example of row echelon form. What was the point of that? What was the point of that? Okay. Alright, so we got that? Okay, and it's row echelon form just because each of your equations starts with a different variable. So that's why we call it row echelon form. So sort of our operations that are allowed with our equations that we're allowed to do to solve these equations to get row echelon forms, we're allowed to switch the equations so we can put them in any order. We're allowed to multiply an equation by a number, any whole number, or we're allowed to add or subtract two equations to create a new one. Hi, my dear. I put your stuff out here. Sorry. Do you get your stuff done? Alright, so we're going to solve this system that's already in row echelon form for our three different variables. So we're given the system x minus 2y plus 3z equals 9, y plus 3z equals 5, and z equals 2. Okay, and so when we take a system that's already in row echelon form, the easiest way to solve it is to back substitute. I already know what z equals because it gives us that in the equation. So I'm going to back substitute z into my second equation to solve for y. So doing that, then I get y plus 3, z is 2, so times 2 equals 5. Which gives me y plus 6 equals 5. And what does that tell me y equals then? Negative 1. And you back substitute both into the top one. Yep. So then once you have your y, then you need to back substitute both y and z into your top equation to solve for x. Did you guys do this in Algebra 2? You didn't? You're supposed to do it in Algebra 2 with matrices, not with equations that look like this. Okay. Okay, so if I back substitute negative 1 in for y and 2 in for z, then I get x minus 2 times negative 1 plus 3 times 2 equals 9. Well, negative 2 times negative 1 becomes positive 2. 3 times 2 is 6. So I get x plus 2 plus 6 equals 9. 2 plus 6 is 8, so x plus 8 equals 9, which tells me x equals 1. So when it's already in a row echelon form, you can easily back substitute to find your other two variables. Okay, so we'll do the same thing with our second equation. So 2x minus y plus 5z equals 22, y plus 3z equals 6, z equals 3. Alright, so this already tells us what z equals. So we're going to back substitute to find y. So I do that, I get y plus 3 times 3 equals 6. Well, 3 times 3 is 9, so y plus 9 equals 6, which tells me y equals negative 3. So then I have to back substitute both z and y into my first equation to solve for x. So 2x minus negative 3 plus 5 times 3 equals 22. Okay, well, minus a negative becomes a plus, so 2x plus 3. 3 times 5 is 15. So 2x plus 3 plus 15 equals 22. 3 plus 15 is 18, so 2x plus 18 equals 22. If I subtract 18, then 2x equals 4, so x equals 2. I don't like these. These are easy because they're already in reduced row echelon form. It gets hard when they're not in reduced row echelon form, yes. Yeah, that's what we're doing next. So we have to actually make them be in row echelon form. And I don't like them because they're time consuming, not because they're difficult. They just take a long time. Alright, so if I look at example 3, I have x minus 2y plus 3z equals 9. Negative x plus 3y equals negative 4. And 2x minus 5y plus 5z equals 17. Alright, so there's certain things that we're allowed to do, one of which is we're allowed to combine two equations, add or subtract two equations in order to make a new one. And you're only going to ever deal with two equations at a time. So if I take my top two equations, I'm going to try to get rid of my x so that my second equation only has a y. So I'm going to ignore this one for now. So if I do that, then since these are both the same except they're opposite signs, I'm just going to add my two equations together. Doing so then, negative 2 plus 3y gives me 1y. 3z plus nothing gives me 3z. And 9 plus negative 4 gives me 5. So my new system is x minus 2y plus 3z equals 9. Y plus 3z equals 5. And my bottom equation stayed the same, so 2x minus 5y plus 5z equals 17. Okay, now that I have it like that, I know that I have a partial reduced row echelon form because my x and y are both the first two leading equations. That means that I need to get this one to where I just have my z in order to finish. So you can multiply an equation by anything. So I'm going to take my top equation, I'm going to multiply it by 2, and then I'm going to combine those ones, first and second, or first and third. So 2 times x gives me 2x. 2 times negative 2y gives me negative 4y. 2 times 3z gives me 6z. 2 times 9 gives me 18. Doing that, then I can subtract my 2 equations to get rid of my x's. So 2x minus 2x cancels. Minus a negative becomes a plus, so negative 5y plus 4y equals negative 1y. 5z minus 6z gives me negative 1z. And 17 minus 18 gives me negative 1. So my new system is x minus 2y plus 3z equals 9. Y plus 3z equals 5. And negative y minus z equals negative 1. So that tells me that I'm really close to having my 3 equations solved in reduced row echelon form. I just need to combine these ones to get rid of my y's. So y plus negative y cancels. 3z plus negative 1z gives me 2z. And 5 minus 1 gives me 4. My new system is x minus 2y plus 3z equals 9, y plus 3z equals 5, 2z equals 4. And I now have it in row echelon form because I have my descending variables. So now that we have it like this, we get to back substitute. If 2z equals 4, what does z equal? 2. So I've now solved for my first variable, and I'm going to back substitute to solve for my y. So y plus 3 times 2 equals 5, which tells me y plus 6 equals 5. So what does y equal? Negative 1. I then get to back substitute again with both of my variables. So I get x minus 2 times negative 1 plus 3 times 2 equals 9. Negative 2 times negative 1 becomes positive 2, plus 6 equals 9. So x plus 8 equals 9, which tells me x equals negative 1. Is it a positive one? Yep, it's supposed to be a positive one. You're right. Okay. So let's do one more like that, and then we'll do one that's a little simpler. Alright, so I'm given the system x plus y plus z equals 6. 2x minus y plus z equals 3. 3x plus y minus z equals 2. Alright, so the first thing I know I need to do is I need to get rid of the 2x in my second equation, so it'll be solved for just y. So, some of the things we're allowed to do, operations we're allowed to do, we're allowed to multiply by any number, and then we're allowed to combine 2 equations. I'm going to deal with just my first and second equation and ignore my third one for now. If I do that, then 2 times x gives me 2x, 2 times y gives me 2y, 2 times z gives me 2z, 2 times 6 gives me 12. And my other equation was 2x minus y plus z equals 3. Now I'm going to subtract both of those equations to get rid of my x's. Minus a negative becomes a plus. So 2y plus y gives me 3y. 2z minus z gives me 1z. And 12 minus 3 gives me 9. So my new system is x plus y plus z equals 6. 3y plus z equals 9. And 3x plus y minus z equals 2. Now I get to deal with just my first and third equations because my second one is done. I have it solved for the y already. So I'm going to get rid of my x's first. I'm going to multiply my top equation by 3. 3 times x gives me 3x. 3 times y gives me 3y. 3 times z gives me 3z. 3 times 6 gives me 18. And my third equation was 3x plus y minus z equals 2. So I'm going to subtract them. Doing so, then my x's cancel. 3y minus y gives me 2y. Minus a negative gives me a plus. 3z plus z gives me 4z. And 18 minus 2 gives me 16. So my new system is x plus y plus z equals 6. 3y plus z equals 9. And 2y plus 4z equals 16. Alright, so I need to get rid of the y in my third equation since there's nothing that I can multiply 3 by to make it 2, or 2 by to make it 3. I'm going to multiply them both by the opposite coefficient. So 2 times 3 gives me 6y, 2 times z gives me 2z, 2 times 9 gives me 18. 3 times 2 gives me 6y, 3 times 4 gives me 12z, 3 times 16 gives me 48. And I'm going to subtract. So y minus y cancels. 2 minus 12 gives me negative 10z. 18 minus 48 gives me negative 30. Alright, so I'm left with the final system of x plus y plus z equals 6, 3y plus z equals 9, and negative 10z equals negative 30. Well, if negative 10z equals negative 30, what does z equal? 3. So we can now back substitute. So 3y plus 3 equals 9. We subtract 3, then 3y equals 6, which means y equals 2. Then if I back substitute again, I get x plus 2 plus 3 equals 6. which means x plus 5 equals 6, which tells me x equals 1. 1, 2, 3. How creative our book authors are. Alright, so we're going to do one that's just a 2 system, and then we'll be done. So we're given 3x minus 2y equals negative 1, and x minus y equals 0. Because this is just a 2 system, these are things we've been doing already. It's what you just quizzed on yesterday. So multiply our bottom equation by 3 so that they'll be the same. So 3 times x gives me 3x, 3 times y gives me 3y, 3 times 0 gives me 0. I then need to combine my equation. So I'm going to subtract. 3x minus 3x cancels. Minus a negative becomes a plus. A negative 2y plus 3y gives me 1y. Negative 1 minus 0 gives me negative 1. So I know y equals negative 1. So then I back substitute to solve for x. So 3x minus 2 times negative 1 equals negative 1. Well, negative 2 times negative 1 gives me positive 2, so 3x plus 2 equals negative 1. So 3x equals negative 3. So what does x equal? Negative 1. Okay, so 2 systems, pretty quick and easy. That's what we were doing on your quiz yesterday. When it comes to 3, it gets a lot worse. We're going to work on 5, 25, 11 through 16, and 19 through 32. We're going to work on it for the next 2 or 3 days or so.